Hi, it's Gadget UK here again. This time we're looking at an A3640. This is the 040, you know, a Motorola 68040 CPU accelerator board for the Amiga 4000. I think it'll fit in a 3000 as well, actually. I think the 3000 has this same connector here. So this came from one of my patrons over in the Discord channel, actually. Just looking at the connections underneath, it looks okay. You can see these caps here are kind of like floating a little bit, so someone's had a bit of trouble, because I think the reason they've had to do that is the footprint. Can you see they're probably larger than the actual pad placement there? So is it 5mm I think you need? These are a bit bigger. These are about 7 or 9 or maybe even 10, you know, a centimetre, something like that. Anyway, I've ordered a cap kit. We'll replace these caps in. There's only 5. You've got 3 there and then 5. He did mention he thought it might be the connector, CPU connector. I don't know if it means this one, because these two here are pretty close to this actually, so don't really want to have to take that off, but I might have to. The alternative would be to reflow from this side these connections here, if we thought it was a bad connection, but it's probably going to be, if anything, a damaged trace or something. You can see a wire there, can you see that? There's a wire on that cap. And I saw a wire somewhere else before. Oh, there it is. Yeah, on that leg there, it's kind of going underneath it to a wire just down there. So from what I understand, this was working, but somewhat flaky, I think the way he described it, for the last year, and then it just suddenly stopped working. And he's tried a few different processors in it, I think, and tried it in a few different systems, and it's not doing anything. So worst case, it could be one of these, you know, faults on one of the PLDs or something here, these GALs I think they are. I've got a programmer that should be able to read these, but it's the pain of having to take them off and, you know, stick them back on. I could stick sockets on for whatever I remove, but that becomes a bit of a hit and miss thing, doesn't it? You know, if you're just going to go, right, let's just take that off and test it, and then put it back on and then take that off and test it. That's a waste of time, and there's a bit of risk involved. This chip here is crooked, can you see that? That looks like that's been off there and put on at a slightly weird angle. Again, the solder points on that side of it look a bit dodgy, and the bottom two there. I'm guessing this chip here is affected in the same way. So what I might do, well, we'll test to start with, and what I might do is remove these, inspect around there, reflow these chips here. Even that pin there is a little bit questionable. Clean the CPU connector. I'll do that first before I do any solder or anything. We'll clean that up if it's still not working. Then we'll do these things and just go from there, really. So just testing the A4000 motherboard here. It's a while since I used it. You can see something super interesting here that will be a subsequent video. So booting from the 030 board there, my system is still working. So let's switch it off. Take the CPU card off. Now the pins look pretty clean there for the moment, so I'm not even going to clean those up. I'm just going to try it. Now it's set to internal. That might not be correct, you know, the jumpers. I'll show you those in a minute if we have to change them. So let's just make sure that's firmly on. It is. And make sure nothing's shorting anywhere. Let me just move that wire out of the way there. There we go. Yeah, no bridges or anything. It's just pin 1 is up here. I did check that just to make sure he'd not sort of stuck that on at the last minute. And switch it on. The first clue to me there is a problem is that LED there is not flickering. Now it's important to note I've got Kickstart's 3.9 ROMs in here at the moment. So I've removed the card there. I'm just going to swap these jumpers over to the external position and try it like that. And we'll try it again, so just pay close attention to that LED. Nope, that is not booting. So I like to go with a little bit of vinegar on these. You could use deoxit or something that's obviously less aggressive, if you like, but it's pretty weak acetic acid anyway, but it will just get any oxidisation off there. So I've got a cap of IPA there. Let's just dry the toothbrush off. I don't think it's going to be that, but we've got to go through the motions, I guess, just with the simple stuff here. and a bit of hot air, 100 degrees with a high airflow. Yeah, you can sort of kind of brush it off the board, you know, not brush it and blow it off the board. You can see it coming off that corner there. Obviously you need to be careful, IPA is flammable. So with the jumpers set to external for the clocks, for both the 90 and the CPU clock, it started to boot actually, but then seemed to crash, and I got repeated behaviour the same way, but only when I put a tiny bit of pressure on the board. You know, like, I'll show you, as it's in the slot, I was like holding it like that. So instead of letting it sag, holding it, and started to boot, which makes me think this is all about this slot here. Now we cleaned with the vinegar and IPA, and we just squashed that a bit thinner. The idea is to get this super thin so that you don't damage this, but just get it, there you go, like that, in there, and just clean over those with a bit of deoxit, nice and carefully. You can see that, that's black. So maybe this is all about a bit of oxidization on these connectors. If you get stuck, don't force it, because you may well bend a pin out of position. Let's fly on that side and do exactly the same thing. Right, let's try that now. I've got the compact flash card in there. I made the mistake of testing it without the compact flash card a second ago. Yeah, it's still not booting. I'm watching that LED there. If that flickers, you know it's starting to boot. So let's just lift it the same way. All I'm doing is holding it like that. Nothing. Now when I did it before, I held it down here a bit. Nope. Just make sure that compact flash card is in, because I have had problems with that in the past as well. Nope. Let's try the opposite. Let's just put a bit of pressure there. Down here. Nope, I don't get it. I don't get it. So you'll have to trust me when I say that it's at one point it did start to boot but then crashed. Well, on a few tries there, you know, I repeated it and it just kept booting and crashing at the same point. And at the time I thought, oh, it must be my Kickstart version. So what I'm doing here is just flooding a little bit of vinegar under here. The theory is that maybe some of the electrolyte leaked under there, and is the issue. It's kind of been a bit intermittent. So if we soak a bit of vinegar on there first of all, and as I say, we'll just try and flood quite a bit just under, around that area. There you go, right underneath it, and we'll leave that for a few minutes, and then I'll clean it with IPA again. Do the same thing, flush it all out, get the hot air, blow it down. The interesting thing was I was lifting the board just a little bit like that, not a lot, just a degree or two, and holding it like that, and it booted, which makes me think it's about this, but there's no caps around that. It looked clean as it was. I don't know, I see something there. What's that? Is that a bit of corrosion? That's just a bit of dirt. Yeah, I'll inspect with magnification and some light and look down there to see what I see in terms of the actual pins. But anyway, we'll leave that soaking there for a little bit first. So the other thing I noticed here, can you see this? There's a wire with a piece of kynar or something coming through onto a trace. Now I measured that and it seems okay, but that was the point. After I measured that, I then plugged it back in, and that's when it started working, and it was not working. So I think what I'm going to do is just add a bit of flux to the actual wire, try and scratch the wire first, add a bit of flux to the wire, reflow that, just to make sure it's a really good connection there. What we might need to do, and as I say, I've ordered a cap kit for this anyway, pull this off and solder the wire on this side here, because that might be the issue. It might be that the wire there, where's it gone now? I've lost it. Here, is not making a good connection. It's the only one I can see under there like that. As I say, there are one or two around here as well. Yeah, they don't look clever, that's why I want to recap it, but let's just do that. Let's just rule that out. So that is so small, I can't get any closer. I won't be able to see what I'm doing, so I'll just get a tiny little bit of flux onto that wire. I have just scratched it with my sharp implement. Hang on. Switch the soldering iron on. Now the problem with heating things like this is it may come loose on the other side, so we might add to problems here. We'll just see. The next thing I'll probably do after this, if this doesn't make any difference, is take the cap on the other side off, actually. And yeah, again, I'm sorry, you can't really see, I can't see. Just going to add a bit of solder to there, hang on, and try and just flow that, there we go, fire. And then we'll just pull sideways like that to flow over the trace as well. That should be it, I think. It worked first time. As soon as I plugged it in, it worked okay. Now, this compact flash card is not booting, let me show you. Can you see that? Getting scrambled graphics there. But it is booting, that is awesome. That is awesome. The reason this compact flash card may not work, it's for a, it's got an 060 build on it. And I notice it does something weird with the video there, like sometimes I lose the video. I've got that now where the screen's just gone. Let's try again. Yeah, look, it's consistent. I've never had that level of consistency with the boot there. So let's try it without a compact flash card in, because if we get the sticky disc in screen and that's okay, that kind of gives me some confidence it's alright. I mean, I'm pretty confident already because I showed it before, got like a black border around the outside, and then the centre of the screen is like a dark, super dark grey. You don't tend to get that unless it's started to boot. Ah, okay. Well, that's good news actually, because hang on, let me just try something. I had the same problem with the TF. I had the same problem with an 060 accelerator here, so that makes me wonder if there is a problem with this A4000 actually. So after cooling down again, that stopped behaving again and it stopped working, it wasn't doing anything. So I think the next thing I'm going to do is pull that cap off there actually. Let's have a look underneath it. I'm not sure whether it'll work without this cap. I'm not sure I've seen any schematics for this. We'll just get a little bit of flux around there anyway on those 2 points. We can clean it up in a minute, but let's just bring the hot air in. Let's just turn the airflow down a smidge. And we'll just remove that cap. There we go. Yeah, you can see the wire comes right out here in the middle. I'll give you a macro in a minute. Let me just get some IPA on there, let's clean that up. So I am not sure how an attempt has been made to fix that actually. It looks like the trace kind of comes right down here under the crystal. The crystal at the moment obviously is a bit hot. Right, so I think I know what the issue is. I plugged 2 or 3 wires around here. This cap, I've just measured, it is just on the supply rail, you know, across VCC and ground. So we can test it without it. It will work fine. You could probably remove all these electrolytics and it would run okay. The only reason I was checking that is because I didn't know whether there was some sort of bespoke reset on here or something. Using a cap. The size would be the clue. 22 wouldn't be a reset cap. Well, it could be. Anyway, that's not the issue. It didn't make a difference after doing that. I'll just show you. So if I switch it on, you can see no activity on the LED. Switch it off, switch it on. And I've been repeating the cycle here quite a number of times. I'm sorry the rain is masking me out. It's unavoidable. See, nothing at all. So again, inspecting around the caps, there's a wire comes out of a via here. I'll show you on the macro in a minute. And there's next to no solder. It's no wonder this doesn't work. Whoever's done these fixes here, they've done a relatively good job with some of the trace fixes, but then they've not put solder on, they've not scratched the via on both sides and soldered the via, as well as having the wire through it. So the wire's through it, and that's fine, it's joined onto the trace on the other side correctly, but it just comes up through the via and just kind of hangs into the via. And the via is the problem. So unless you've soldered onto the via here on this side, you're not going to get connectivity. This is the problem. And I know that because if I just press this wire here, hang on, let me just point you up. So you can't see what I'm doing. I'm pressing down on that wire on the via with my nail. Watch the LED. Hang on. See it? Flash. Flash. And if I hold it, we get further than we did previously. It not only boots up, we actually get the desktop, which wasn't happening before. And I'm trying to hold it. It's going to be a bit fudgery in a minute when I move the camera. Just bear with me. Yeah, I couldn't quite hold it all the way, but trust me, I had the workbench desktop up a minute ago. So let's deal with that via now. So we're on a macro here. It's hard to hold this in the right position here. Let's see if I can just use the probe. There's a wire coming through this via here. And then if I flip this over, it comes out here and well, it doesn't go anywhere. It kind of just hangs into the via and doesn't do anything. So that's the problem. There's just like a wire, no solder on the pad, if you like, nothing on the other side. So that's the issue there, I think. I'll be very surprised if that is not the problem. It is literally just sat there. The wire is just sat in the via. There's no solder on either side of the board. It's like someone went, okay, we need a wire there, and then forgot to blooming solder it. So it's like they put it in place. I'll have to do this on macro, I think, well, with magnification, because I can't see what I'm doing. I've scratched the via surface. You can just see a little bead, well, there was a little bead of solder there. I'll report back in a minute. I can't do it this way. So after bridging that via, I think it's fixed. Let's just see. Fingers crossed. Let's see if it's reliable, if the desktop boots up. And it isn't. Yeah, so we aren't quite there yet. Let's try it again. It's getting further though. It's reliably booting from the hard disk now. So I think that there are a few via problems on this. It's not just one thing. Yeah, got the same thing, at least it's been consistent. Let's just reseat the card again. Give it another try. Yeah, consistent garbage. Well, if I boot any other accelerators, everything's fine. Anyway, if I just show you the old cap, I'm going to swap this cap. Well, we've removed it. We've tested without it. I want to just reinstall the cap. Now that I've, I don't know if you can see, plugged a few of the vias there. I redid this one here and made sure that there was a good connection right through to the other side. Plugged a via there, plugged another via here. I think there's 3 in total. And then the issue I identified with the point down here. There was a wire here already on this, but it wasn't soldered on the via on the other side. So after doing that, that's when we gained the 100% stability. I'll plug the via next to it as well. I'm going to stick a new cap on here now. I've ordered some brand new Panasonic ones. These are Panasonics as well, as far as I remember. If we test this now on the ESR meter, I'll just show you this. Hang on. So this is a new one. You can see it's slightly higher. Instead of 22, it's 23. 0.44. It's a nice low ESR. Now if I test the one that was on there, look at that, 1.14 ohms. So it's probably within spec. Originally it would have been not far off that, but it is higher. So anyway, whereas these ones, can you see the legs have been bent on them? Someone's, before they put the caps back on, bent the legs out because they've been struggling to solder them in the locations there. So hopefully the ones I've ordered the similar sort of can size to this and not that size, because if they're that size they're going to be quite hard to mount. Anyway, I'm going to get this one on there. It's worth pointing out something that I haven't mentioned at up to this point in the video, and that is Commodore. made a mistake with these boards at manufacture, and 3 caps, it might be these 3 here I suspect, were mounted the wrong way around with regards to the polarity. So of course that's why these leak, and I think that's why these 3 have been swapped, but somebody's done nothing with these 2, and the fact that traces have been affected here shows these have leaked anyway. So you know, we may find if we just swap these 2, we may suddenly find our problems are solved. So what I might just do, because I've got 2 of these of that size, I'm still waiting for some more, I might swap that one as well. So how can you tell if you've got the one of these around the wrong way? If I measure from one of these 74 series chips here, ground is in the bottom right, you know, I pin 1 notch here, there's the where the semicircle would be. But if we measure continuity from there to each of the pads here, you can see that's got the plus on it. And if we measure from VCC, that's the positive. So it would suggest that that is one of the ones that's marked the wrong way round, I think, because the hang on, yeah, the ground is that one, positive is that one, and if you look at the positive indicator there, assuming that's what that indicates, that is incorrect, that's ground. Yeah, the band on these is all going towards the ground, but that positive there is not right. So this one down here, you can see the negative band is going to the positive. Yeah, so that one's been put back on correctly, I think. Well, we'll check it. But the interesting thing is, this went to somebody else. He said that he'd got another person who repairs boards and things like this to have a look at it, and said he couldn't find anything wrong with it, which, yeah, I just don't know what to say about that. Couldn't find anything wrong with that, really. Someone's looked at that and gone, can't find anything wrong with it. So I've got some flux on there already. Let's just try and absorb the solder. There we go. Whilst there's very little corrosion on this, this has got away very lightly. Some of these accelerator boards are almost destroyed. You know, you get these ones leaking around here, around that. Yeah, you can have a difficult time. You'll have to remove the CPU socket there, and yeah, it might not be cost effective to repair. That's one reason why you can buy replacements for this PCB. Chucky, forget his name, but Chucky created a replacement. He took one of these boards, removed all of the components, cleaned up all the solder, and then scanned it on both sides, loaded it into something like Sprint or something similar, and then traced, you know, all the connections and created a new board layout for it, cloned the original. Besides that, I think he reverse engineered some of the stuff as well, you know, got all the PALs and things for it, or created his own versions of the PALs. So yeah, you can buy a replacement board if your board is completely destroyed. Zoom back out a little bit there, because I don't know that that was blurring. Anyway, I'm not sure if this is going to hold in place or not, but I'm just going to do my usual of just trying to trail a little bit of solder just onto that point there, quite a lot in fact. That's it, that's one side done. And try and get it down there, and then I can just touch the solder point with, hang on, I'm going to melt that jumper if I'm not careful. Touch the solder point with no solder on the tip, just to even the size. I've got to be careful because there's a little wire there, that one of the ones that I've plugged, and I could end up bridging the negative side here to that point if I'm not careful. I cannot get onto that. Yeah, there we go. But you can see here why this perhaps is hard to do if you get the caps the wrong size. If the footprint makes it so you cannot get onto the pad here, it's going to be super hard to get them back on. And that is the part of the problem with the caps that are on there now. Anyway, you can see the cap is in position. No, that's not made any more reliable. Can you see that? Now I'm not even getting the display, we're getting the same thing we had before. I can switch my ROMs back to fast speed now. Actually, now I know that that is ruled out. What I said before was incorrect, it was just a blooming coincidence. Coincidences have to be challenged. What I mean by that is when you think you've proven something by, like we did, by switching that ROM over, and oh, suddenly it's booting. Yeah, switch it back again and just see if it's still booting, because yeah, you can convince yourself of a situation that's not true. Anyway, it's back on the fast position. We've reseated that card, so is that going to make any difference? Is it about connectivity on the card? Oh look, that's working. This is the thing, so there's a little bit of this going on with that as well, a bit of confusion in terms of, wow, that seems alright now. What the hell? I'm confused. It's now more reliable in the fast position than it was in the slow position. What is going on? Seems rock solid. The reason I'm doing that right click is often when I did the right click here, you'd see some corruptions at the bottom, then the screen would just go off. Always on the right click. The desktop, you could leave it sat there like that, it'd be fine. As soon as you right click, bang, it would go. Which is strange. Anyway, I'll continue to test. So it is strange how we had the issue on the first power on, but then it's been alright ever since. I've loads of power cycles, disconnected it, reconnected it, disconnected it, reconnected it, and I can't get that graphical glitch back again. So I'm wondering if it's intermittent. It's certainly a lot more reliable than it was yesterday. I didn't show in the afternoon yesterday, after it had been reliable for a number of hours, I left it off for a bit, switched it on, and then had the same problem as this morning, and I spent probably an hour trying different things, trying to rule things out, and getting the same issue where it wouldn't really get beyond the boot to the desktop. It would then just go crazy with the graphics. And just coming back to the point I made earlier about these replacement boards, you can see one here. This came from Stephen Leary, actually, the limited black edition. Now this is for the 060, but I'm not sure whether this will accommodate an 040. But obviously, it was done at the same, followed on from the 040 board here, and you can see it's pretty much the same. If you look at the chip positions here, they're identical. All these main customs, not customs, 74 series, are in the same sort of positions. I'm curious as to where these resistor packs are here. There may be SMD ones or something like that, or separate resistors on the other side by the looks of things. Yeah, it's got a spot for the delay line there. Everything's in the same place. The crystal. All of these gals/pals here are identical. Those ones, block 4 there, and the cap positions as well. Actually, the nice thing with this is I can use this, I think, to check the connectivity. When I get around these caps here, if I go, oh, where does that trace there go? I can actually look at this PCB, which is great. You can see Stephen included a connector there as well, so I've got that, which is really nice. Anyway, that'll be a future video. So I've got 3 pieces of Captain tape there. Let's just try and get a little bit of flux. I don't always use flux when I'm desoldering SMD things like this, because all it does is just burn up. You'll see it'll just burn up, and then it'll take just the same amount of time to remove. That's what I've found. Hopefully the pads aren't too bad around this. Soon find out, I guess. See the flux there, it's literally all burnt up already. So like anybody who says add lots of flux on before you try and desolder, well yeah, it kind of helps spread the heat initially, but then it just burns off. You can see the smoke coming off now, look. Hope this cap doesn't shoot off. Oh, so difficult to get the right spot there. This is the problem with using caps, they're too big for the job. You can't actually heat the pad. It's coming off there, I think. There we go. Right, let's just try and mop up the solder there. As I say, I think there's a wire through there, I'm not sure. It looks very strange, that pad. Yeah, I don't know what's going on there. It's really weird, that. This one kind of looks normal. Let's just try and heat that. Oh, it's difficult to try and heat it and get the braid in. I think that's a wire as well, actually. I see 2 wires. So it's a similar story here, can you see? Someone's created like an artificial leg. Now, I think I'm going to remove this and remove that one. Can you see this one? It's in the wire, but there's like barely any solder on this side of it. Now, flipping the board over, you can see there's like a little bit of solder there and a bit of solder here, but it's just the fact that on the other side, they are not very well adhered here. So I'm not got confidence that those are going to be reliable enough. So I think what I'll do is I'll just heat here, very carefully pull them out, stick my own bit of kynar through the other side, make sure you've got a nice flow on both sides, bend the kynar over to make a pad, do the same here, make a pad. I'll show you before we commit to soldering the cap on. You really need something under there to secure the cap as well. I might just get, I don't know, I want to avoid that trace. I was going to say a bit of epoxy or something just to hold it just in one tiny area there. I mean, this in theory, the wires here in theory would be enough to hold it, but you know what, any kind of like knock, it's going to move. Right, so I haven't needed to replace them. What I've been able to do, can you see? Got a tiny bit of solder and flux onto each of the points there. So we've got a good join, and I cut off the extra bit here and squished this one together, folded it round, and the bit here was like a curly bit that went off, and I've just trimmed that off actually, and pulled it away from this wire because the curly bit was quite near that wire there. So I think that should be okay. I think we can just flatten that down and get the cap back on there. It's as I say though, you really need something to secure the cap. What I might do is just use a tiny bit of hot glue on the sides here after I've got the cap in position. That might be the best solution. So let's just test which one's ground. I forget already. It's not that one, it's that one. While we're here, let's just test VCC is good on that one. Yeah, and it is. So ground is down here. So in this case here, I think the silk screen is correct actually. Yeah, the problem here is these are now going to need bending a little bit, like that. Or there's going to be nothing for me to solder onto, if that makes sense. Yeah, I can just about see where I need to solder onto there. I'll have to do this off camera, I can't see what I'm doing from here. And there we go, so you can see, got a little bead of solder on that side and a bead of solder on that side. And it's not too crooked, it looks pretty straight. The print is not as straight, you know, the alignment there. But it's going to be always very difficult to deal with something like that. So I want to be super careful in my approach here. Just want to get a little bit of IPA around that area. Trying not to, put pressure on the cap, because what I don't want to do is damage those connections. Yeah, that's not too bad. Let's go and test it. Yeah, still working fine. However, after cooling down, that problem is back again. Oh god, it's enough to drive you to despair. I might try just reseating the card again. Maybe there's a bad connection. Maybe there is something still wrong with this board. Yeah, second boot, it's alright, look. I don't know, I can't explain that. I do not know what would cause that. Up. Do you see what I mean about the right click? It just did it. Try it third time. It might be third time lucky. Yeah, got the desktop. And it's gone again. The interesting thing, I noticed that when that happens, there's like an extra flash on the LED from the hard disk after the desktop is displayed. Almost like there's some sort of extra read going on that doesn't happen when the problem doesn't occur. It's a bit strange. Shall I tell you when it gone off now? Right. A second read there. That was alright this time. Ah, but look, right click, same behaviour. Let me try reseating the card. I mean, the wires around that cap we've just swapped out look okay actually. and I know that the power and ground connections are good on it. Now it's gone again, look. There we go. Pads are looking okay. Let's just flip the board around. You can see I've got some caps and tape there. Now these ones, I'm not looking forward to removing because there is a wire or two around them. That one's sort of fallen off, look. And that one as well, I think. The nice thing with these is because they were stud off the board, it's made them easier to get off. You can see the wire. There's a wire here, look, I think. So the pads on that one are alright, it's just this one. I think that wire, yeah, that wire's going through a wire there. I'm going to pull that out actually, I think, and we'll replace it. And heat the wire. I can see it going through to the other side and it's soldered well on the other side, but as I said, I'd like to replace it, I think. Is that going to come out? Yeah, there we go. And on this side, what have we got here? Another wire? Yeah, we've got another wire there, look, for that one. Let's just get rid of that blob of solder off it. Yeah, we'll just gently clean here. I think while I'm here, I'm just going to reflow these chips, the edges. So you could argue I don't need to clean this off at this stage. So I've got a little bit of flux around those ICs there. I'm using the old iron here, so it's yeah, got a really crusty, corroded tip on there, and I'm just going to dab into these and try and reflow them. Just add a little bit of solder actually, just because the solder points there do not look that great. So let's try that again. Sorry if I'm blocking the shot here a little bit. Yeah, you can see that those end 2 points there looking a lot cleaner. I'm not going along the whole chip there, it's just that edge. This one here, I'm going to go along the whole thing. And we'll just bob in and out. First one, then we've got a bridge, I think. Looks a lot cleaner. Anyway, you get the idea. I'll do the same on these two here. So I'll just clean around there with some IPA. I will get the toothbrush onto this afterwards. I'm not going to bother doing that though until I've fitted the caps actually. Can you see this little cap down here? It's got a bit of oxidisation on. This one has as well, and it's not really oxidisation, it's actually the electrolyte has actually touched the cap there. You know, the contacts are dull. Can't get in down there. Because I can't get the fiberglass tool down there, I'm just going to touch the surface of that solder there like that. Anyway, that is looking a lot better. Now, there was like some contaminant on the top. It's very difficult to reach. Let's try and extend the fibres. Yeah, I can just about squeeze in there. That's better. There was like, again, contaminant on top of it. It looked a funny colour. So I've decided to clean around this bit before I fit those caps. I'll tell you why. As soon as we've got those caps on there, I can't really brush around here, can I? You know, I'm going to be severely limited. So I'd rather do this way, so I can clean up now and get these super clean. Get all the bits of flux and stuff out of there. I just hope we get some more stability after this, because it's still doing that thing where when it's cold you kind of get the graphical corruptions when it boots the desktop, but it is booting every time. That's for sure. It wasn't doing that at the start. So I'll try and show you how I've fixed these connections and how they were done originally, really. Try and feed the wire, okay, you can see what I'm doing here, through the via. Yeah, I'll need to heat that point because it's obviously blocked on the other side. I could unblock the hole, it's easy just to heat it and push it through. So you can see here, I pushed it into the hole, heated it, it's come through the other side, I bent it over. I'll solder that in a minute just to make sure you've got a good join there. The thing I want to do now is just position this. We're going to pull this wire over here like that. I'm going to leave a little bit of length on it because I'm going to kind of coil it round itself, if you like, to make a little point to mount onto. So it's going to be very much like the other ones were up there. There's not a lot else you can do because there's no pad. The key here is to press it down and then bend it around. So you probably cannot see here. I'm just going to hold it like that and then bend it around here. So that's that one back on. Yeah, the wire's bare. There's nothing to short to there. It's away from the wire. I'm going to get a little bit of nail polish just over that wire just to secure it and isolate a little bit. But we just need to get this one back on now, and then just cut off this bit here. I'll reflow that there and cut it off. So file cap going back on. This one is mounted the wrong way on the board, so this is correct. Actually, I'll show you that in a sec. You can always just hold it like that and move it a little bit if you feel it's not in position, but yeah, that is, and it's nice and flat. Solder the final point. So clean with a little bit of IPA. Cleaning the wider area there because I just use a bit of braid to remove the solder from the pads. So that's our ground, and if we test here, that's ground. But I don't think you can see there's a plus, so yeah, that would have been wrong at factory. Same with this one, left hand side of it is ground. That should be ground. That should be ground, yeah, and that should be ground. Yeah, all correct. So sorry, it's a bit like night vision here at the moment. I've spent ages chasing my tail. That graphical corruption issue I was having, I worked it out. It's a voltage drop. This connector here, I reconnected it, and then suddenly the problem went away immediately, and I tried everything prior to that. I tried heating various things on my motherboard and on here. I went round the chips one at a time, trying to work out, because it seems to stabilise over time. Anyway, let me just switch that back on, and I'll measure the voltage. I'll show you. So sorry that's really dark, I'll brighten it up for you, and we'll be back in the daylight in a minute. You see that? 4.72 volts there. So that is really weird. And if I measure the actual power connector coming in, hang on, it's gone to 477 there. Ah, okay, that means it's this blooming connector from the Amiga kit. Yeah, so apologies, I know you can't see very well, but if we measure one of the 5 volt wires on here, hang on. So this is the same power supply, look at that, 5.14. So the voltage drop is here. It's here. Let's switch this off. So back the following morning, and the amazing thing is, this is the first time I've had a from cold, and it's blooming cold in here, it's snowing outside, from cold boot, first time. Look at the voltage. Now it's a little bit lower than it was last night. It's going up a little bit there, 4.92, 4.93. But yeah, that was as low in the dark as I showed you, 4.7 volts. That was the issue. It was just about voltage drop on this connector here and on this connector here. So I didn't really explain, but what I did is I got a bit of deoxit. I'll show you actually, switch it off. So I focused on the 5 volt connections. It looks a bit pink in there actually, there's still a bit of deoxit in there. I leaked some deoxit very carefully into the black connections here and those red ones, and then I connected it back up. And the other thing with this adapter here from Amiga kit is, watch this pin here, the red pin, you can pull and push it, and I can feel it sliding up and down the connection in there. So I did that on each of them. Yeah, you can just almost like grab a bunch of them and do that. You can feel them all sliding up and down. Then I measured the voltage. We're up to like 4.87, I think, or 4.89. So I thought, okay, well that's increased it a little bit. But measuring on the actual connectors here, we're still 5.14, so we've still got some voltage drop, which is why I then got a bit of deoxit into each of the connections there, and then just unplugged and plugged that back in about 3 or 4 times. You can see after reconnecting that there just to demonstrate, can you see we've got slightly lower voltage, 4.9, it's a 0.2 of a volt, 0.02 of a volt lower than it was a minute ago. So that just goes to show you can get bad connections on those power adapters. But you wouldn't believe how long I spent yesterday, probably best part 3 or 4 hours messing around with this. After I completed the recap, the thing that I noticed was the same problem I've been having all along, that when the board was cold, this thing would, it would boot okay, and then as soon as you got to the desktop, the graphics would go crazy. And I'd be like, oh my god, what is wrong with this? And then I thought, maybe it's my A4000. Now at that point, I retested with my original 030 card here. This is the one I modified in a previous video. We fitted a Freescale 030 chip there with a full MMU. Anyway, that's another video, I'll link up there. And that booted okay, so I thought, okay, well let's test with the terrible fire card again. And that worked, but I did have some weird graphical things just a little bit, and I thought, okay, so I'm seeing the similar thing with the 4060 now. I wasn't before, so maybe it's my motherboard. So I spent ages going around the board, making sure everything was, these chips that are socketed fitted okay, pressing on various things. I even got the hot air out, and I went round a chip at a time and kept testing, because it was seemed temperature related. So I'd heat the buster here maybe 100 degrees for 10 seconds, switch it on and off. Same thing, same problem, same corruptions, when this 40 card was booting. Lisa, same problem. Every single one of the PLDs, everything around here, everything, pretty much. Then I shifted my attention to everything on here, a chip at a time, only 100 degrees for 10 or 20 seconds. And what ultimately that means is, you heat this chip for 10 seconds and then you feel it. It's not like too hot, it's just like as warm as it is now, after it's been on for 10 minutes, if that makes sense. So it's not like we were superheating anything. Even the delay line, I heated the delay line just for 10 seconds and then tested again. No difference. And I did everything. Every single chip on the 4000, every single chip on here. And that was when it dawned on me. I thought, what's the pattern here? Well, it boots all the way to the desktop. Why is it a graphical thing? What's going on with the graphics? And if you think about it, you're going to get a current dip. The moment the system's finished booting, you've got a certain amount of CPU activity going on, so your current is going to be a certain level. As soon as you engage the graphics, switch the graphics chip on and do stuff with the blitzer and all that sort of stuff, you're going to see more, just slightly more usage there. So you would see where you've got bad power connection like this, you'd see a very small voltage drop, a further voltage drop at the point where that additional functionality kicks in. And that's what it was. It was literally, when the screen was black, this could boot, everything was fine. As soon as the graphics were enabled, you've got that extra current dip there. The voltage drop, drops in accordance because it's super low already. And because it was so low, 4.7 volts, that was the issue. So yeah, a face palm moment. The repair of this has been super simple. It's been just that one wire down there. We did plug a few wires in various places, but those weren't the issue. It was just this one wire down here, and then we've fitted 5 new caps and tidied up the wire and stuff around there, and they're all level. They're not sort of floating off the board like they were, so we are all done. Yeah, so the 040 was very nice. These still ran on 5 volts. The later 060 needs 3.3 volts. The interesting thing with this board, I showed you the one from Chucky, well, it came from Stephen. Thank you very much for that, Stephen, the bare PCB for this board here. But that's aimed initially at the 060. The only difference, as far as I understand, physically between these chips, is there's an additional row of pins on the 060 that the 040 socket doesn't account for, but they're not used, I don't think. And the other thing is obviously that voltage difference that I mentioned. Obviously, you're going to get performance benefits with an 060 if your PLDs, are supporting the 060 differences, but I think think they're very subtle. They're very, very subtle differences. You can literally unplug this, plug an adapter in that supports the 060 pin profile and feeds 3.3 volts to it instead of 5, and stick an 060 on one of these. And in fact, Andy, the guy who sent this to me, he's got one of those boards that he uses with this. So yeah, that's very cool that this board could be used for an 040 or an 060. And in terms of what the 040 brings to the table versus an 030, you've got 4K of internal caches. So I presume you've got an instruction cache and data cache, just like you do on the 68030, but the cache size is larger. I think there was something like 256 bytes or something in the chips. They might be a bit bigger than that, I don't know. But anyway, 4K in this one. It's also pipelined. You've got 6 stages of pipelining going on there. So in layman's terms of pipelining, you know, an instruction goes into a pipeline and then the pipeline gets pushed along, so that instruction, you know, goes to the next stage of the pipeline. Meanwhile, another instruction has gone to the first stage, and you have 6 stages there, which means it's, you know, obviously it's a lot more efficient. These are CISC processors, by the way, and this also had the FPU built in. So the 68882/1, you know, the 2 different variations of the floating point unit you can get for earlier Motorola processors. I think those would run side by side an original stock 68K, by the way. They didn't seem to do many changes to the FPU. You know, it changed from a 68881 to a 68882, where it got there was just a small change there that made it more efficient. I forget exactly what, something to do with 80-bit something or other, I forget. But that 68882 didn't change, you know, so you could run it alongside a 68000, a 68020, a 68030, but by the time they got to the 68040, they integrated it into the chip along with the MMU. Now, just like the 060, there are cut-down versions of the processor that, you know, remove the MMU and FPU, or either or. I don't know, there might be 3 different versions like there are on the 060. The other point with that FPU is it dropped the IEEE transcendental functions. So I've got no idea what that means. It's if you're familiar with mathematics, you know, I mean, like complex mathematics, you'll know exactly what that means. But that functionality was used a lot in some of the demo scene software and stuff. Anything that did fractals and things like that, it used that. So you couldn't run it on the FPU. That's a huge problem in my mind. Why would they drop that? I honestly don't know. I haven't researched that to work out why they dropped it, but they did drop that functionality. Now, Motorola's answer to that was a library or something that they provided, you know, a bit of code that you could compile and run in software, you know, so the CPU, you know, the main CPU would be processing emulation, if you like, of that FPU, that specific FPU functionality. But of course, there's going to be a massive overhead. That was the whole point of having an FPU. So I don't know why Motorola dropped the ball on that. That seems a bit of a shame, really. And performance-wise, same clock speed as a 486. These will outperform 486 in terms of integer and floating point math. And while we're doing comparisons, I guess, it's worth pointing out that the later 060s introduced the superscalar technology, so that kind of put them in line with performance of something like a Pentium. So, you know, the 040s comparable to a 486, the 060 comparable to a Pentium. 486s tended to get higher clock speeds, though, which, you know, pushed them well beyond the 040, you know, if you think back to the DX266 onwards, you know, you got like DX4100 and stuff, and I think they went beyond that, actually. I think there might have been a 133, I can't quite remember now. So I'll do a few benchmarks, and I'll just test a couple of games on this just to show you it working. This is a cold boot again, so watch the LED. Flashing, no problems. The thing I'm amazed at with this, it boots so darn quick. I would say there's very little difference between that and the 060 in terms of boot time. It's incredibly quick. I'm amazed how quick it boots. So if we go into sysinfo, you can see up here it says CPU 68040, FPU 68040, MMU 68040 in use. I've got MMU libs already on this compact flash card. That's probably going to affect our drive speed, so let's just do that. I suspect if I disable the MMU, we may get more performance. I think it's the way I've got it set up on here. Someone did recently tell me that there's a specific thing you've got to do when you've got an MMU. So can you see that? That's actually slower than it was on the 030. we were 1.7 meg on the 030, so, and that's at the same clock speed, 25 megahertz. This is running at 25 megahertz. So we dropped from 1.7 meg to 1.576, which is interesting. But as I say, I think if I disable MMUlibs, in fact, we'll do that. Let's just do that now. So I removed MMUlib there. Let's just test this again. I'm kind of expecting it might be the same as it was on the 030. We might be around the 2 meg mark. It's not. Oh, it's slower. That is slower. So that is interesting. And it's not affected by the MMUlib at all, really, there. The 1.6 meg there, it's roughly the same as what it was before. Let's just test it again. So that is interesting. There might be something more specific you have to do on these. Of course, the other thing is it's got map ROM set, so hang on a minute. Let's just try disabling that. So I'm pulling the jumper off. It's exactly the same. So yeah, that has not made any difference to disk speed. Either the map ROM jumper or playing around with MMUlibs there, but bear in mind I might not have MMUlibs set up properly. Sometimes, you know, the specific things you need to do in the startup script and stuff. So yeah, I'm not an expert at that. If you know what to do with that, let me know in the comments down below. But versus the, you know, the way this is configured versus the 030, this is slower at disk access, which is weird. So next we'll just do a normal speed test, and let's have a look at that. That should be staggeringly faster. There we go. Yeah, exactly. It's on the ball there, isn't it? If you look at the stock benchmark there for an A3640 running at 25 megahertz, it's the ratio reported is 1. It's exactly the same. It's spot on. So compare that to the line below there. That's an 030 running at 25. It's a lot quicker, isn't it? Considerable. It's like 4 times faster. I'm going to give you a benchmark here in this Amiga Intuition based benchmark as well. Let's do integer math, see what that reports. As I say, this was as fast as a 486 running at the same speed. Yeah, it's right up there, look, that's incredible. It's perhaps not in terms of the other benchmark we just looked at, you know, the overall one. It's like just more than double a 3000 running at 25, so it's not staggering there on that. Let's just do the beach ball test. Yeah, that's about the same as you'd expect on an 030 with an FPU, I think. Maybe it's a little bit slower actually. Let's try a memory test. Yeah, so you can see the memory on an 040 is kind of crippled versus the A3025, and this is the thing. So, you know, and that scales up. If you went to an 030 running at 50, it's going to be way faster than an A4040 in terms of the memory bandwidth there. So it's one reason why people tend to skip the 040. I still think it's a great processor. I'm glad I'm going to have one, which I'll explain in a few minutes. But yeah, the kind of natural progression really is to go from an 030 to an 060. The 040 brought some nice functionality and performance in general, but it had that memory bottleneck there. So and we'll just do a matrix test on it as well. Yeah, you can see there it's almost double an A3000 running at 25. And before I forget, just coming back to that beach ball test, that wasn't using the FPU. I always make this mistake. That was very fast considering it wasn't using the FPU. It was using single core math or single CPU math, I think. If we change these here to co-processor math, I think that's what that stands for, and then do the beach ball test. Oh my god, what's happened there? That's not doing anything. That is not doing anything. Now that may be because of that lack of transcendental functions. I think that's perhaps what that is. I don't know. Let me know in the comments below. It hasn't frozen. It's just not doing anything. I'm wondering if it's right. It's doing something with the FPU there, and it's expecting a result, and the FPU's going, I don't know what to do. I don't know what that instruction is. That's a possibility. So that, I don't know. Post your comments down below. Of course, there is a chance the FPU's bad inside this processor, but I don't think so. I don't think so. We can try Doom. Let's give that a go. I'm guessing Doom's could run pretty well because, you know, cast your mind back, let's say 486 performance almost. Let's do NTSC low res. Yeah, that's pretty good actually, if you look at the movement speed there. I need to connect a joystick up actually. Yeah, this game's weird in that you use the joystick and the mouse. So it's like, in fact you can just use the, if I just centralise the cursor, you can just use the joystick. So yeah, that's nice and fast actually. Can't open the door though, I need a keyboard I think. Anyway, you get the idea, performance there is excellent actually. Bit of tearing, but it's really good. And it goes without saying WHD load is an absolute must with an 040 or an 060. Just because lots of the games in the WHDL load library have all been updated to, in many cases, to work with later processors and stuff. You know, they've had fixes and things done to them. Everything just runs really well with the WHD load. If you try booting games from floppy, you may have problems. A bit like that when I tried to run Dune on Cather's 060 machine there, you know, his A4000. It was a bit glitchy, that game, but you boot it from WHD load, it ran fine. And I'll just show you some clips from the Frontier demo here. Let's just let that run through. It's always nice to see this demo. Lots of people seem to hit this as a benchmark, just to see how fluid the how many frames you get more than anything. You can tell how good it is in terms of the frame rate. Silky smooth. You can tell how much better that is there. The speed the lasers are firing and stuff is crazy. And the actual, just the movement of those ships, you can tell there's no loss in dropped frames and things like that. You know, it skips a fair bit in terms of the number of frames on a standard 68,000. But of course an 030 runs this really well. If you run this on an 030 running at 50, it's going to look almost identical probably. Now I think Ocean Machine may run on an 040. Could be wrong. Yeah, I think it will do, but it can't allocate enough memory there. So that's an interesting point as well, I think I'll just talk about. With something like the 040 and the 060, one way to get better performance would be to have local RAM. So the problem with this is you've got Ramsey on the A4000 down here, that's the bottleneck in terms of access to the fast RAM. And of course the speed of that fast RAM and stuff as well. You know, it's got some limitations based on the sims you've got on there, but also Ramsey. But if you had some localised RAM on here, and some of the 060 accelerators, maybe some 040 ones, I don't know, will have facility for local RAM. So you don't have that bottleneck there of having to go through Ramsey, which is got, you know, it is a bottleneck in its own right in terms of the speed it can actually pass data to and from that RAM. So I nearly forgot, we need something to secure the caps in a few places, because two of them were the ones with missing pads. There might be three actually, now I think about it. There wasn't. There was this one here. This had a pad missing, and that one had both pads missing. The other caps were okay, so we just need a little bit of hot melt glue. I'm taking a leaf out of my mate Vince's book here and actually using hot air. The reason being is I always find it a pain to get my glue gun out. Might not be hot enough though, actually. Let's just increase it. Let's just feel that. Yeah, that's not hot enough. Let's just go up to 200 maybe. Yeah, so you can see I've secured that one there. There's some glue between that cap and this cap. A little bit of glue stuck out on the edge there, and around there to the edge of the socket. So that's not going to go anywhere. If it gets knocked, it's going to buffer the impact. I've discovered one of the easy ways to do this is just to chop a piece of the glue off, stick it where you want to secure, and in this case it's this side. I'm going to stick some on the other side in a minute, and then just heat it, and it will sync and join to whatever it's attached to. So let's just heat it back that way a bit. So it's just going to be wedged next to those resistor packs there, look. That should do the job on that side. So on the other side there, we'll just chop a piece off and wedge it. So you can see I've got a nice beefy piece there, which should be, look, just big enough to wedge in there like that. And if we melt that and get it at the right angle, that should just hold that in place. We're not hot enough here to melt the socket, by the way, we're just hot enough to melt the hot melt glue. Yeah, that's starting to melt. You can see it's starting to sink down there and grip and mould and fit itself into the cavity. See that? That's perfect, absolutely perfect. One thing I will note, can you see this has got dirty as the repair has progressed? So you might want to stick tape or something over these things. I didn't do that peel of that there, that was coming off already. But we'll stick a label on there just to indicate when this was recapped. Yeah, so there's no mistaking when it was done. So as frustrating as it was, the crazy amount of time that I spent just trying to get to the bottom of a voltage drop issue, it raises a valid point that I guess is useful in the context of this video. A fault with one of these accelerator boards, either an 040 or an 060, you need to make sure your supply that's getting to this board is good enough. Some old power supply that's perhaps on its last legs, if you were using an 030, you may find it's okay for the most part, and then you fit an 060 or an 040 and you start to get weird things happening. The first thing you should do is measure between ground, you know, as I showed when we're measuring the connections of the caps, ground and VCC on here. You can measure across these little bypass caps, that's the easiest thing. See if you've got 5 volts there. If you're seeing less than about 4.85 volts, ideally you want 4.9 volts or more, but if you're seeing less than, say, 4.85 volts, start looking at your power supply, because that might be the issue. And it might not necessarily be your power supply. You may just find, if you get some contact cleaner into your connections and things on wherever your power comes in there, you may find that resolves your problem. And in case you're wondering what I was, why was the 060 board here from Terrible Fire not behaving exactly the same way? Now, it did towards the back end. I started getting graphical issues with this as well, but very early on when the graphical problems started on this, I would swap over to this board and this board would be fine, rock solid. And there's a clue. I think this has got a VRM. I think there's a voltage regulation module under here, because the 060 uses 3.3 volts. Now you might think, well, how is that relevant? Well, the 5 volts is low, 4.7 volts. That is going to cause problems with this. 4.7 volts is not low enough to cause a problem with the VRM stepping down to 3.3. So that explains it entirely. It's like the stability was not the motherboard that was having problems, the stability was the CPU. But you can see the glue here, can you see it's right up to the CPU socket and right in between those two caps there, so they're supporting each other. And then up here it's supported there between the two resistor packs, not on the solder point, so you know you can still measure on these things here, and again right up to the socket but not touching the chip. I will be taking that chip off in a minute, so yeah, very much appreciated. So thank you very much to Andy for sending this for me to have a look at, but also letting me keep the processor, which is amazing, because that's going to mean that I'll have an 040 board here and an 060 board, because I will be fitting that to the board build I'm going to do using Chucky's board there that came from Stephen Leary. If you would like to support the channel, please see the Ko-fi and Patreon links down below. I'll catch you in the next video.